This presentation is based on a project that we conducted as part of the STRIDE UTC to investigate the use of CV data for different applications in transportation engineering and planning. And the project was a collaborative effort between Florida International University, University of Alabama, Birmingham, with Dr. Virginia Cisiopico, and the University of Florida with Dr. Siva Srinivasan. The big picture is for us is to develop a framework that show how connected vehicle data and in general also automated vehicle data can be used to estimate the performance of the system in terms of travel time reliability, congestion measurement, and level of service, environmental impact, and so on, but also to derive a new performance measure that can be used to assess system performance. And the challenge is we have a lot of promise that the data that will come from connected vehicle can be used for traffic management. However, there is a lot to be known about the ability of this data to allow the estimation of performance measures, either those that are currently being measured by existing sensor technologies or third-party vendors, or through the use of or through the development of new performance measures that are currently not being used for transportation system planning, design, and management. And in that aspect, then, we investigated the use of basic safety messages that comes from connected vehicle to estimate various measures. So in addition to the traditional measures like travel time and travel time reliability and environmental impacts, we also investigated the use of standard deviation between vehicles, standard deviation of individual vehicles, the time to collision, number of oscillation, acceleration, deceleration thresholds, and so on, as measures of performance of the system. And we have obtained those measures on a smaller segment compared to what can be measured with existing technologies. So we subdivided the freeway into 300 feet segment per lane to estimate these measures for, and that allows us to identify the location of the congestion or the location of the safety issues, and also to predict those problems using machine learning in real-time operation. So there is a need then to update the central software of Traffic Management Center to allow it to receive and use these type of new measures and process those data, do the calculation either in the center or in the field at the edge, to or both to estimate those new performance measures, considering the amount of data that will be available. So we need an effective and efficient way to process this data and use it in real-time operation, and also to archive it for future use in design and planning. We think that these measures will allow agencies in the near future, not too far future, to better estimation and prediction of system performance. And it can be used as part of both offline planning and design and of the highway, or even of transportation management plans, but also in real-time processes, including, for example, the activation of the plans or even derivation of the plans in real-time operation, so that the system will operate in a better performance in terms of mobility and safety. We expect that this can impact the operation and management of the traffic and improve them both, as I mentioned, mobility safety and environmental impacts. So, for example, if the ramp metering or dynamic speed limit can be activated, and the parameters of these management strategies set based on a prediction of safety and mobility in the next 10-15 minutes, then we expect that this proactive strategies will be able to reduce the congestion and improve the different performance measures that we are trying to impact by implementing the strategies. This is my presentation today. If you have any question, please let us know, and want to thank Stride for funding this interesting project, and my team, my colleagues in the team, Dr. Virginia and Dr. Siba. Thanks a lot.